In March 2025, Chery Automobile Corporation Limited announced Falcon Advanced Driver Assistance Systems, Falcon ADAS. Falcon has 3 levels of road driving support: Falcon 500, Falcon 700, Falcon 900, and Falcon Off-Road. Chery plans to offer Falcon ADAS option in more than 30 models in 2025. iCar V23 includes Falcon 500 in Intelligent Driving Edition model. Chery and iCar informs about total number of 23 ADAS features, without communicating, however, any further details on them. I would like to look closer at Falcon 500 in iCar V23 and discuss the following. What is ADAS? How it is different from autonomic driving, AD? What levels of driver assistance we have currently and where Falcon 500 belongs to? What is the hardware behind Falcon 500 in iCar V23? What is the list of iCar V23 usual driver support and ADAS functions with brief description? This should help to choose options when considering iCar V23 purchase. The Society of Automotive Engineers, or SAE International as it is known now, proposes 5 levels of drivers support systems from level 0 to level 5. Advanced driver assistance systems are referred to as ADAS, are level 0, level 1 and level 2. Autonomic driving is level 3, level 4 and level 5. Level 0 to level 2 requires driver to be in constant attention and be ready to take over controls immediately. Even if L2 car seems to be driving on its own, it is still the driver, not manufacturer, who is responsible for accident and failure to comply with traffic rules. Level 3 to level 5 assumes the car is capable of making decisions, and in level 4 and level 5, the driver does not need to be competent at all, and in case of failure, it is manufacturer who is responsible. Example of level 4 car is Waymo Autonomic Taxi. There is controversy about which particular system falls into which level, but you see them in promo materials, so it is worth to know what these levels are and what do they mean. Breaking down ADAS levels. Level 0 offers warnings to the driver and short, basic automatic intervention, like autonomic emergency braking, AEB, in obvious collision scenario. There is very little debate that in this situation, when the collision is about to happen, the car should slam the brake on its own. L1 takes control of the braking and throttle, or the steering wheel temporarily, to help avoid an accident. So the car can briefly control the stop-go or the left-right, but cannot do both at the same time in level 1. Example is adaptive cruise control, where the car will manage the brakes and throttle to keep the set distance to the car in front. Or it can correct steering from drifting out of lane, often called lane centering, but is not able to drive on the road on its own autonomously. Level 2 is extension of level 1. ADAS can handle brake, gas and the steering in emergency situation together. The car can lane follow without driver controlling it. It can do automatic overtaking, etc. The best known level 2 are Tesla's autopilot and full self-driving system. Level 1 and level 2 use combination of multiple sensors mounted on the car, video cameras, radars and lidars. Falcon 500 in iCar V23 is positioned as level 2 plus. What does it mean? The plus indicates that apart from sensors on the car, it also uses information about the car position, geolocation, GPS, and map/roadbook to predict what the road ahead is like. This allows systems like navigation on autopilot, NOA, to drive the car with minimal intervention from the driver on known roads. So iCar V23 Intelligent Driving Edition is level 2 plus. Now, let's look at the hardware behind iCar V23 ADAS. A lot of it is manufacturer's secret. I have no access to service manual or the actual car, so I cannot have a peek inside. Here is what I know from official sources. There are 22 sensors mounted around the car. 1 8-megapixel front camera, 4 3-megapixel surround cameras, 5 millimeter wave radars, and 12 ultrasonic radars. 2 specialized chips control advanced safety and driving functions. One of the chips is well-known Texas Instruments TDA4VM, likely to be the ADAS domain controller, or in simple words, ADAS brain. It is integrating all available information about the car, its surroundings and GPS position. It does process all this information in custom software that was developed by Chery engineers and sends information to driver and also some commands to the brakes, motors and steering. The TDA4VM structure contains 2 ARM Cortex A72 CPUs. There is a general graphic processing unit, 4 specific hardware accelerators. There's one for deep learning, AI, there's one for depth and motion, there's one for vision processing, and one for video encoding and decoding. There is Texas Instruments digital signal processor, C7X core, that helps analyzing video and audio in real time. There is image signal processor, converting raw video image to more usable form, and it has ability to link any external device through various communication protocols like CAN, Ethernet, CSI, PCIe, SPI, I2C, and possibly many, many more. Simply put, it is a very powerful and energy-efficient computer running a car-specific code, doing just ADAS and enhanced safety tasks. Because all is contained in a single package, it is called System on Chip, or SoC. I'm guessing current cost of TI TDA4VM chip is in the range of $200–250, but obviously it is useless without software loaded onto it. The other ADAS chip, called Journey 3 or J3, comes from Chinese company Horizon Robotics. Horizon Robotics controlled 49% of Chinese self-driving chip market in 2023, employs more than 2,000 workers, and aims to sell 10 million chips in 2025. Horizon Robotics' focus is on AI solution in automotive industry and safety cameras. It has strong links with Volkswagen through joint venture Horizon. I'm sure working with VW helps Horizon Robotics to understand European market very well. No surprise, Chery claims that Falcon's autonomous driving capabilities have been adapted to accommodate varied driving conditions, including European roundabouts, Middle Eastern desert highways, and densely populated roads in Southeast Asia. The company has also obtained European Union certification for vehicle cybersecurity and over-the-air software updates. Its fleet has collectively logged 4.5 billion kilometers in autonomous driving. Well, let's hope this claim proves itself when iCar V23 is available in Europe. The Journey 3 chip was released in September 2020. It uses Horizon self-developed brain processing unit BPU 2.0 architecture and is fabricated on TSMC's 16 nanometers node. Provides 5 tera or trillion operations per second while using 2.5 watts of power. I do not think it is available to buy on free market, but likely cost is around $125. Horizon Robotics chip does AI image processing, but I have not found information on what exactly happens in the chip, what camera or cameras it uses, and what is the output to TDA4VM, how both chips work together. The most likely Falcon 500 in iCar V23 architecture is the Horizon J3 handles the seeing, while TDA4VM handles the thinking and doing, making real-time decisions, ensuring safety, and commanding vehicle actuators. And here is the proposed architecture. So the front camera module with high FPS rate and low latency feeds the picture into the Journey J3 SoC. This is where all the artificial intelligence is analyzing the image. So it is used for recognize what traffic signs are around, what is the position of the car on the road, and what is around the car, what are other road users doing, what objects we have, is it the car, is it the pedestrian, which direction it is going. This information is sent over Ethernet to TDA4VM that runs the custom software and does all the planning of driving using sensors. It does all the safety monitoring and action, and it sends commands to brakes, motor, and steering. It also communicates with the driver. I put together a list of iCar V23 features in terms of ADAS and the usual, let's call it old-fashioned driver supports. Basically, I took all the acronyms and headlines from iCar V23 manual and put them together below with short description. Auto hold, autonomic parking. Brakes are on continuously until the driver goes back on accelerator. So when you stop the car, when you put the foot on the brake and then you release the foot from the brakes are still on until you start driving again. ABS, good old anti-lock braking system that momentarily releases the brakes when wheels are locked under heavy braking. Electronic stability control, ESC, applying braking to a wheel to stabilize the vehicle. Braking force distribution, EBD, prevents rear wheels from locking and the car from nosediving under heavy braking. Hydraulic brake assist, HBA, increasing brake force when brake pedal is pushed very fast when the driver attempts emergency braking. HAZ, emergency braking strobe function. HDC, hill descent control, maintains set speed on descent. HHC, hill hold control, prevents from rolling backwards on an incline. TCS, traction control system, prevents wheel slipping under acceleration. DTC, drag torque control, increases motor torque to prevent driving wheels slip when we lift off foot from acceleration pedal. TPMS, tire pressure monitoring system. HMA, high beam assist, automatic switch between headlights, high beam and low beam depending on the road, location and oncoming traffic. ACC, Adaptive Cruise Control. It maintains set speed and distance to the vehicle in front. DAI, Vehicle Departure Alert, reminds the driver to resume driving when the vehicle in front moves on, like under traffic lights. LDW, Lane Departure Warning, alerts when crossing lane line. LCC, Lane Centering Control, keeps vehicle in the central between lane lines. LDP, Lane Departure Prevention, steers the vehicle back in the lane. BSD, Blind Spot Detection, when there is a vehicle detected in neighboring lane, the light on the mirror switches on. LCA, Lane Change Assist, alerts driver in case of collision risk when changing the lanes. ELCA, Emergency Lane Keeping, actively prevents lane change in case of risk of collision, so steers car back if we try to change the lane and there is a car already there. DCLC, Lane Change with Lever, or Discretionary Lane Change. Vehicle changes lane on its own when indicator is switched on. AEB, Automatic Emergency Braking, applies brakes when risk of collision is detected. FCW, Forward Collision Warning, alerts the driver of potential collision with a vehicle or object directly ahead. RCW, Rear Collision Warning System, alerts the driver of potential collision with a vehicle or object directly behind. FCTA, Forward Cross Collision Alert, warns driver about approaching vehicles in front of us from the left or from the right and actively brakes to avoid collision. When we try to move out of the parking space, it is going to warn us about the traffic parking area. Rear Cross Traffic Alert System, analogous system when we are reversing. DOW, Door Opening Warning, alerts in case of risk of door opening against another moving vehicle close by. So it's similar to blind spot alert. If the car is going close to our vehicle, is approaching our vehicle, and there is a risk of opening the door, then we'll get this warning. APA, Automatic Parking Assist, parks the car after detecting parking space. So that's basically automatic parking. HPA, Home Zone Parking Assist. Car memorizes usually parking space location and automatically follows the path to get there. So when we approach our usual parking spot, we can activate this and the car is going to take us on its own to the usual parking location. RPA, Remote Parking Assist. Moving car into parking space can be controlled from outside via Bluetooth and app. So basically we can remotely control the car steering, braking and acceleration with obviously sensible limits through the mobile phone. FTR, Forward Tracking Reverse. The vehicle can reverse along the route it just drove forward. So when we go into parking space, then it can reverse back on its own, memorizing the path it did going into the space. TSR, Traffic Sign Recognition. And finally, navigation on autopilot. This is self-driving using sensors, geolocation, GPS, and map. Likely in Falcon 500, limited to motorways with clear lane markings. Town self-driving comes in Falcon 700, so slightly more advanced system. I hope that gives you a good idea of what iCar V23 Intelligent Driving Edition is capable of.